So this batch is H2M1. So in last lecture we have covered the topic of vector scalars के बारे में थोड़ा बहुत पता चल गया था कि what does it mean by vector and what are scalars. तो वहाँ पे we had sufficient example that displacement is a vector quantity and distance is a scalar quantity. So whenever a quantity is having some direction we will call it a vector quantity. तो ये बताओ, if you are traveling from A to B, you are taking two different path. One is straight from A to B and one is like a roadway, that is a curvy path. So you are going with a aeroplane directly from A to B, straight path, and another path is of roadway, that is a curvy path. So this path will be your distance. क्या होगा? That will be your distance. हाँ या ना? This will be your distance. एक मिनट वेट करना, just a minute. Because this curvy path will not be having any specific direction. Whenever you draw a tangent, that will give you the direction. उसका कोई exact direction नहीं होगा. But this will be your distance. इसको क्या बोलेंगे? We will call it distance. And this A to B will be having a specific direction, that is from A to B. So that we will call it displacement. क्या बोलेंगे? Displacement. Clear? बोलो. Is it clear?
Yes, sir.
We will assign the sign of distance as S, and we will call it delta S. Delta means delta is change. Delta means change. So delta S is length covered, total length covered, or total distance covered, length. Whenever I call length, that means distance. And displacement, we will assign the sign X. So displacement will be delta X. What will be delta S? Delta S will be net length covered or distance covered, and displacement will be delta X. X is your position. ये आपका position होगा. X will be your position. Clear? S is also a position mark. This is also a position mark. That is a length mark. Suppose if you are going on a road, अगर रोड आपका कर्वी ऐसा है इस तरीके से, and you are getting some stones. यहाँ पे stone mark is 220 kilometer. Then you reach another stone mark, that is 228 kilometer. So this is your S1, this is your S2. So just up यहाँ से you can calculate that how much distance you have covered. So this is delta S. So delta S कितना होगा बताओ? What will be delta S? You started from 220 mark and you reached to 228 kilometer milestone. Okay, then calculate the distance you have covered. कितना आएगा? It will be 8 kilometer ना? Simple. It will be 8 kilometer. 228 minus 220. So that will be 8 kilometer. That doesn't mean that you have covered 228 kilometer. That means you started from 220 kilometer and you reached to 228 kilometer mark. So that means the difference will be your distance covered. But road can be curvy, so stone mark will give you the length or distance covered. But if the road is straight, so this is the mark X. X1, that is equals to 110 kilometer mark. Then next mark is 115 kilometer mark, that is your X2. So what will be the displacement? It will be X2 minus X1, isn't it? So that will be 5 kilometer. But the only difference between displacement and distance is the displacement is the shortest possible path, and distance is the entire length covered during the motion. Clear? Is it clear?
So can you explain that delta S and delta X thing again?
Delta S can be a curvy path. It can be a curvy path, so we will mark it as a S. So that will give you the distance. And X is a straight line displacement path. Okay, so we will mark it as X. Clear? डेल्टा एक्स कैसा भी हो सकता है ना, इट कैन बी कर्वी पाथ, ऐसे रोड हो सकता है इस तरीके से. सो यार,
तो सर डिस्टेंस एस से डिनोट होता है, डिस्प्लेसमेंट एक्स से.
हाँ हाँ, फॉर डिस्टेंस वी विल मार्क एस एंड फॉर डिस्प्लेसमेंट वी विल टेक एक्स. क्लियर. डेल्टा एस एंड डेल्टा एक्स गिव यू द डिस्टेंस एंड डिस्प्लेसमेंट. क्लियर. समझ में आया कि नहीं आया?
हाँ सर.
बहुत सिंपल.
Yes, sir.
नोट कर लो इसे. So what does displacement and distance actually means? That means, suppose if you are going out on your scooty or any two-wheeler or four-wheeler, the speedometer, speedometer, you left home for a coaching or school. This is your home. You are going to suppose if you are going to अंधेरी, अंधेरी, ठीक है, और any other place or to your school, कुछ भी हो सकता है, it can be anything. You are taking this path. You are taking the curvy path, this path. You went to school or college जो भी है, then you come back to your home. So what will be the net displacement? What will be the net displacement? Delta x, it will be 0 because initial point and final point are same. So displacement will be 0. But the odometer of your vehicle will measure the net distance covered. उसमें 0 नहीं आएगा. That will measure the net distance covered. Clear है कि नहीं? समझ में आया? The speedometer will give you the reading that you have covered such length. वो डिक्रीज नहीं करेगा. दैट विल नॉट एक्ट लाइक कि आप घर से जा रहे हो अंधेरी, दैट इट विल इंक्रीज. देन व्हेन यू कम बैक टू होम, दैट इन दैट केस इट विल नॉट डिक्रीज, है ना, डिक्रीज कभी होता ही नहीं है. सो यहां से यू कैन कंक्लूड डिस्प्लेसमेंट मे इंक्रीज और
सर स्पीडोमीटर डिस्टेंस की रीडिंग बताता है या डिस्प्लेसमेंट?
ना, it will always give you scalar reading, है ना. In a speedometer we call it speedometer because it gives the reading of speed. Speed is a scalar. And in its odometer, speedometer ऐसा होता है. If I take the manual speedometer, so one portion, है ना, जो इसका ये रहता है marking, that will give you the speed. ये speed देता है. This is the speed bar, है ना. Speed chart यहाँ लगा रहेगा. And this section will be odometer. This one. This give you distance, and this is speed. So speedometer gives you the reading of speed as well as distance, not the displacement. Clear? समझ गए?
Yes sir.
Displacement may increase or decrease, but distance क्या decrease कर सकता है? Distance always increases. Clear? Distance
So can you
कभी,
please repeat that line, displacement may increase or decrease?
because displacement is a vector quantity. It's a vector quantity. When you come back to home, when you start from home and come back to home, your vector will be 0. This will be a null vector बन जाएगा, है ना. Starting and final point are same. So in that case displacement will decrease. पहले बढ़ा अंधेरी तक and it decreases when you come back. So displacement is a vector quantity. That's why it increases or decreases, depends on the direction. But distance is a scalar component, and it will always increase. आप आगे जाओ पीछे जाओ, doesn't matter. Clear? Displacement only depends on initial and final position. Clear?
Yes sir.
चलो नोट कर लो इसे. चलो, so just tell me what are the properties of distance and displacement. ठीक है, क्या क्या प्रॉपर्टीज हैं डिस्टेंस एंड डिस्प्लेसमेंट की. Just a minute. Displacement First, displacement. We will denote displacement by delta x. Delta x is displacement. Clear? It's a vector quantity. क्या है? It's a vector quantity. Clear? Distance delta s. Its distance. It's a scalar quantity. क्या है? It's a scalar quantity. Delta s. Distance. Scalar quantity. Displacement depends on initial and final point. Distance depends on net length covered. Doesn't matter on initial and final point, है ना? Depends on net length. Clear? May increase or decrease. Displacement may increase or decrease, but distance always increases. Distance never decreases. Always increases. Clear? So this is all about distance and displacement. And one conclusion you can write here, that when you take distance and displacement, you can write delta x will always be less than or equals to delta s. Magnitude of displacement. Whenever you take mod, that means you are taking only magnitude, not the direction. So magnitude of displacement will be always be less than or equals to distance. Just tell me in which case the distance and displacement will be equal. कब होंगे बताओ?
Straight line.
When they are moving in the same direction. Same direction में जब चलेंगे, only in that case distance and displacement will be equal. Clear?
So in the same direction and in a straight line, right? Same direction, straight line, right?
Straight line, हाँ straight line in same direction in straight line. When they are moving in a straight line और वो reverse नहीं लेता है, it's going forward only. Forward या reverse जो भी आ रहा है, but direction should be same. In that case, distance or displacement will be same. For example, if a vehicle is going straight 20 meter from initial and final point. So in that case, delta x will be 20 meter and delta s will also be 20 meter. लेकिन अगर उसने यू टर्न ले लिया, इन दैट केस डेल्टा एस विल इंक्रीज बट डेल्टा एक्स विल डिक्रीज. क्लियर? सो if it is going in only one direction, in that case only net length and net displacement या distance and displacement will be same. Clear है कि नहीं? Is it clear? क्वेश्चन दे रहा हूं मैं. There is a question. This is a zero marking. This is zero marking. X is equals to 0. Man is standing at a marking of x is equals to 4. He walks up to x is equals to 8. He walks up to x is equals to 8. Then he takes U-turn and he come back to x is equals to -2. He come back to x is equals to -2. ठीक है? This is the entire path, है ना? यहाँ पे आ गया. This is the final point. This is all about the question. You have to find net delta x and delta s. ठीक है? Net displacement and net distance. बताओ कितना है? So answer, delta x is
6.
6 meter. Yeah, correct. And delta S, this is
40.
6 meter. This is 6 meter, and this length is, first he covered 4 meter in forward direction, then he covered 4 meter in backward direction, then he covered 6 meter in backward direction. Clear? So what about the delta S? Delta S कितना होगा? बताओ. What about
40.
length?
40.
First 4 meter in forward direction, then reverse direction 4 meter, then 6 meter. So answer is 14 meter. Clear? And what about delta X? Delta X depend on initial position and final position. Okay? So it is 6 meter. It's minus 6 meter. Minus 6. That mean it is having a direction in backward direction. है ना? Backward direction आया है. Displacement can't be negative. This sign shows negative sign. Negative sign shows that you are moving backward. Moving backward. By default, this direction is positive, and this direction you have to take negative. So minus sign just shows that you are moving backward. Clear? यहाँ से समझ में आ गया? यहाँ से कर लोगे? बोलो.
Yes, sir.
Yes, sir.
Any doubt?
Yes, sir.
Any doubt in this question? Sure. Next. This question. बताओ. Solve this question. चलो. This is 40. This is 10 meter. So that will be 30 na? 30 meter. So when we calculate distance, कितना आएगा? It will be first 10 meter, then 50 meter, then he goes down 40 meter, then 55 meter, then 30 meter. कितना आया? Is it 185?
Yes, sir. Yes, sir.
Yes, sir.
And what about displacement? Displacement will be कितना? This first 50 meter, this one 50 meter, and then 55 meter. You have to take this straight path A to B directly. ठीक है? So it will be 50 plus 55 meter. So answer will be 105 meter. Clear? Is it clear? बोलो भाई, clear है?
Yes, sir.
चलो, एक मिनट है, जल्दी से नोट करो सब लोग इसे. क्वेश्चन भी नोट करना है. We are moving to the velocity and speed part. इसको जल्दी से देखेंगे. बताओ, what does it mean by velocity? Velocity means rate of change of position. Rate of change of position with respect to time, or you can say the net displacement, or you can say the velocity is rate of cover of displacement. This देखो, change of position is displacement. That means you're talking about delta x. Clear? So velocity क्या होगा? It will be delta x by delta t. Delta x by delta t. Clear? So velocity we will denote velocity by v, vector sign, because velocity is a vector quantity. It will be displacement by time taken. Clear? It's a
Yes,
vector
sir.
quantity. Velocity is a vector quantity. ठीक है, इसको नोट कर लेना. Vector quantity. Same as displacement. As displacement is a vector quantity, so velocity must be a vector quantity. है ना? It must be a vector quantity. In the same way, speed. What will be speed? Speed क्या होगा? Speed will be rate of change of length or distance. Rate of change of rate of change of length with respect to time. ये समझते हो ना WRT with respect to, clear, time. So that it's a scalar quantity. It's a scalar quantity. It has no magnitude. It has no direction. Only magnitude is there. So we denote velocity by v as distance by time taken. Clear? Distance by time taken. V is equals to delta s by delta t. So velocity is a vector quantity and speed is a scalar quantity. Velocity will be having magnitude as well as direction, but speed will be only having only magnitude. Clear? Speed will only have some magnitude, no direction. इसको note कर लो, note it down. Then we will move to the detailed version of velocity and speed. Velocity and speed will be having two versions, है ना? दो version होंगे, average and instantaneous. First note down this slide.
Yes. So
चलो. So velocity and speed are of two type. The velocity will be of two type. First is average velocity, and second is instantaneous velocity. INST, I will call it instantaneous, okay? Instantaneous velocity. In the same way, speed will be of two type. First is average speed. The second is instantaneous speed. Yeah. AVG means average. AVG is average, and instantaneous INST I will call it. INST and instantaneous I will call it. हर जगह पूरा नहीं लिखेंगे. Clear? So velocity and speed are of two type. दो type के होते हैं. First one is average and second one is instantaneous. Clear? What does it mean by average? Average का मतलब क्या होता है? मैं यहाँ लिख दे रहा हूँ. V average is delta x by delta t, net displacement upon my time taken. While instantaneous is at that moment what is the rate of change of displacement, dx by dt. So dx by dt will give you instantaneous velocity. In the same way, average velocity is not average velocity, average speed. Average speed is delta s by delta t. This is the average speed, and instantaneous speed will be, it will be ds by dt. ds and dx will be same. For a small fraction, dx and ds will be same, but we will have the discussion of instantaneous velocity and speed in later slides. पहले हम लोग we will take average velocity and average speed. ठीक है? पहले इतना नोट कर लो, then we will start with the average velocity and average speed. Clear? पहले नोट करने से. Note on the slide. Now we are starting the average velocity and average speed. First we will take average velocity. Average velocity and speed. Clear? So first we will take average velocity. Average velocity is simple. This is always between two position, है ना? It is always between, यहाँ पर लिख लो, between two time interval or position. ठीक है? So average velocity, in case of average velocity, you just calculate if object is going from A to B, A से B जा रहा है, तो हम यहाँ पे बनाएंगे इसको. ठीक है? तो यहाँ पे एक चीज रह रही है, ग्राफ इज लेफ्ट, है ना? ग्राफ थोड़ा सा रह गया है, लेकिन वी विल टेक द ग्राफ. ठीक है? वहाँ पे एक एक्सटी ग्राफ रह गया था, तो यहाँ पे मैं अभी बनाऊंगा उसको. ग्राफ हमने यहाँ पे प्लॉट नहीं किया था, हमने सीधे वेलोसिटी स्टार्ट करी है तो इसके बाद ये ग्राफ पहले कर लेंगे, डिपेंड करता है कि व्हेन वी स्टार्ट द ग्राफ वी विल सी. सो एवरेज वेलोसिटी क्या होगा, व्हाट विल बी एवरेज वेलोसिटी इफ ऑब्जेक्ट इज गोइंग फ्रॉम ए टू बी अलग अलग वेलोसिटी से गया, फ्रॉम ए टू बी विद डिफरेंट, फ्रॉम बी टू सी विद डिफरेंट, है ना, अलग अलग से गया. सो एवरेज वेलोसिटी v average will be delta x by delta t. सिंपल, ठीक है. दिस इज फाइनल पोजीशन माइनस इनिशियल पोजीशन अपॉन में टोटल टाइम टेकन tf माइनस t इनिशियल. दिस इज ऑल अबाउट एवरेज वेलोसिटी. दिस इज एवरेज वेलोसिटी दो पॉइंट के बीच में, ठीक है.
सो टोटल टाइम में ऐड नहीं करेंगे?
ऐड क्यों करेंगे? सपोज आपने मोशन स्टार्ट किया व्हेन द क्लॉक वाज शोइंग यू 11 am, है ना, 11 am, and now the clock is showing you 2 p.m. So what will be the entire interval? It will be 3 hours, na. So you have to minus 2 p.m. That is, यहाँ पे इसको 2 p.m. को ऐसे लिखो, स्टैंडर्ड टाइम that will be 14, है ना, 14. So what will be the time interval? कितना होगा? It will be 14 minus 11, है ना. So this is your TF and this is your TI. ऐड क्यों करेंगे? इंटरवल निकालेंगे ना.
और अगर इंडिविजुअल टाइमिंग्स दी हो तो फिर ऐड ना.
टाइमिंग कैसे देगा वो? दैट विल शो यू द क्लॉक ना. क्लॉक बताएगा दैट एट दिस मोमेंट इतना टाइम हो रहा था, एट दिस मोमेंट इतना टाइम हो रहा था. तो यू हैव टू कैलकुलेट व्हाट इज डेल्टा टी. क्लियर?
हाँ सर.
चलो, नेक्स्ट इज एवरेज स्पीड. क्लियर? Average is simple. This is all about distance. So that will be delta s by delta t. Simple. Net distance covered upon my time taken. As you know that delta s is always greater than or equals to delta x. So you can conclude when you divide it by delta t, the same expression you will get. That means average speed will always be greater than or equals to average velocity magnitude. Clear? समझ में आया कि नहीं? बोलो. Is it clear? बोलो भाई.
Yes. हाँ सर.
You can always take this expression that average speed will always be greater than or equals to average velocity का magnitude. Clear? इसे नोट करो. चलो, नेक्स्ट इज, हो गया ना सबका बेटा?
यस सर.
डन?
हाँ सर.
चलो, नेक्स्ट इज इंस्टेंटेनियस. आई विल कवर अगेन दीज टॉपिक्स. एवरेज इंस्टेंटेनियस में फिर से बताऊंगा आफ्टर कंप्लीशन ऑफ ग्राफ के बाद भी मैं फिर से दिखाऊंगा क्या होता है. नेक्स्ट इज इंस्टेंटेनियस. सो velocity and speed. So in case of instantaneous, it will be at a specific or particular time, certain time, at a specific time. You have to tell speed or velocity. Speed or velocity. This is about instantaneous. So suppose if a car is moving with a speed, with a variable speed. First, at t is equals to 0, it is started with the speed of 50 meter per second, and then at t is equals to 5 second, it was moving with the speed of 80 meter per second in a direction east direction में, ठीक है. And then it is stopped at t is equals to 10 second. वो रुक जाती है, ठीक है. So this car will be having different average velocity and average speed, ठीक है. वो तो बात ठीक है. But ये बताओ, if question is asking you that what will be the speed at t is equals to 5 second, what will be the speed at t is equals to 5 सेकेंड? बताओ स्पीड कितना होगा, बताओ. t is equals to 5 सेकेंड में स्पीड इज, बोलो.
16 meters per second.
अरे इट्स 80 मीटर पर सेकेंड इज गिवन ना.
Okay, sorry, sir. I just
क्या
divided.
कर रहे हो यार, दिख रहा है. Speed is 80 kilometer 80 meter per second and velocity is 80 meter per second in a direction each direction. Okay, so this is magnitude and this is direction. So velocity will be having magnitude and direction, but both will be having the same magnitude. Both will be having the same magnitude. Clear? So you can write instantaneous velocity and instantaneous speed will always have the same magnitude. They will always have the same magnitude. Clear? समझ में आया कि नहीं? Instantaneous velocity and instantaneous speed. यार कार में अगर बैठे हो, if car is showing you 80 meter per second speed, it's showing you the speed of 80 meter per second. So that's your speed at that moment. And if you say that car is moving 80 meter per second in each direction, so that will be your velocity. लेकिन magnitude तो सेम ही रहेगा ना, आया ना. Magnitude will be same. So when the car is moving, whenever you take instantaneous part, so that means you are taking dx. This is the dx and ds are always same because they are differential length. So when you call it instantaneous, when you calculate instantaneous velocity, it will be dx by dt and its magnitude will be equals to ds by dt, that is equals to velocity, not velocity, with speed instantaneous. Clear? So whenever you calculate instantaneous version, you have to differentiate. Clear? आपको differentiate करना पड़ेगा. चलो इतना नोट कर लो. चलो graph. Now we will see graphs. First one is distance and displacement. Versus time. ये ग्राफ देखेंगे हम सारे. क्लोजली ऑब्जर्वेशन इसका करना है. First I will draw the axis. So this is your xt graph. Displacement, position versus time. This is your st graph. So when you draw the graph, suppose मैं ऐसे बना रहा हूँ, the graph is starting like this, इस तरीके से, it's going like this. इस तरीके से. This is position x, this is position a, this is position b, and this one is position c. This is position c. Clear? ये है ग्राफ, इतना. ठीक है, इसको ठीक से देखना, गड़बड़ हो जाएगा सब, है ना. दिस इज अबाउट पोजीशन वर्सेस टाइम ग्राफ. सो पार्टिकल स्टार्टेड फ्रॉम पॉइंट O, it goes forward A, then up to B, B से it takes a reverse direction में आएगा and it is coming back और C पे आया. ठीक है, तो you have to tell कि net displacement कितना होगा between A and C. What will be the net displacement? So this will be your position XA, आया ना, बोलो. And this will be your position XC. Clear? So what will be the net displacement? Net displacement कितना होगा? It will be delta X. It will be XC minus XA. क्या ये समझ में आता है? Clear?
Yes, sir.
And what about the time? This is TA and this is TC. So what will be the net time? that will be delta t, that is equals to tc minus ta. Is it clear? बोलो.
Yes, sir.
Yes,
अब
sir.
इसी का st ग्राफ वी विल ड्रॉ, है ना. सेम फॉर द सेम ग्राफ आई विल ड्रॉ द डिस्टेंस वर्सेस टाइम और लेंथ वर्सेस टाइम. तो ये बताओ, डिस्टेंस नेवर डिक्रीजेस, डिस्टेंस नेवर डिक्रीजेस. तो द सेम ग्राफ वी विल टेक द सेम ग्राफ. इस ग्राफ को अगर हम यहाँ पे लेके जाएं, इफ यू टेक द सेम ग्राफ, so we will take this same graph, यहाँ पे लेके जाएंगे. बट फ्रॉम b it started decreasing, है ना. डिक्रीज कर रहा है कि नहीं, है कि नहीं. फ्रॉम b o से यहां से गया a, ठीक है, चल गया अप टू b, इट्स ओके. लेकिन डिस्टेंस तो कभी नहीं घटता ना, इट कांट गो डाउनवर्ड, है कि नहीं. So how you will draw st graph from xt graph? You will take a mirror image from the point where the graph is going downward. तो जैसे ही when you take the mirror image, this graph will go upward. ऊपर जाएगा कि नहीं जाएगा? When you take the mirror image, so this will be your st graph. समझ में आया कि नहीं आया? देखो, B से C the displacement was going downward, so displacement was decreasing. But distance never decreases, it always increases. तो यहाँ पे क्या होगा, the graph will be same from O to B, लेकिन at the moment it start going down, तो वहाँ से you will take a mirror image and you will take the mirror image of C, it will be like this. So this will be your distance versus time graph. समझ में आया कि नहीं आया, बोलो.
हाँ सर.
देखो, O to B,
Yes, sir.
O to B, it will be the same graph, but from B to C, the graph is going downward, so you have to take the mirror image, and mirror image will go upward. नीचे नहीं ले जाना है, ऊपर लेके जाएंगे, so that will become your ST graph. When you draw this, this will become your ST graph. Clear? The white one is your ST graph. Clear? This is your length versus time. So it is showing clearly that distance is increasing. All the displacement is decreasing from B to C, but still distance is increasing from B to C. Clear है कि नहीं? समझ में आया?
Yes, sir.
Mirror. You have to draw a mirror. So projection of mirror or image of mirror you have to take. अब पढ़ ही जाएगा, है ना इसका, ठीक है? Clear है कि नहीं? Is it clear?
Yes, sir.
चलो. So this is about distance and displacement graph. How to make displacement and distance graph को कैसे देख के बनाएंगे. If question asking about the distance versus time graph and it is given that xt graph is like this, तो आप कैसे करोगे. from the moment graph going downward, वहां पे क्या करोगे, you put a mirror and you will take a mirror image upward जो आएगा, बस नेगेटिव नहीं होने देना, ठीक है.
सर यू टर्न्स और वो सब के केस में भी ऊपर ही जाएगा ना ग्राफ.
कैसा.
सर यू टर्न, मान लो किसी कार का ग्राफ प्लॉट करना है, उसमें यू टर्न ले रहा है तो भी ऊपर ही जाएगा
हाँ,
ना.
ऊपर ही जाएगा. सपोज कार इज टेकिंग द यू टर्न, so that means it is started from 0 and again it's coming back to the same position. This is your xt graph and what will be your st graph. st graph ऐसे होगा, a to b it will be same, but from b to c you will take your mirror image. From a to b it was same, but from b to c you will take a mirror image. Clear?
Yes, sir.
इस तरीके से इसे नोट कर लो अच्छे से. नेक्स्ट, अब I told you that when you have to calculate average velocity, v average velocity average is delta x upon by delta t. Clear? And instantaneous velocity is dx by dt. 90% question, in 90% question you will only get position versus time, that is xt graph. They will give you xt graph because xt graph will be having the sufficient information. xt को देख के you can draw st, but st को देख के drawing xt is little bit difficult, लेकिन किया जा सकता है ना, बता नहीं सकते हैं, हो सकता है may possible. देखो xt graph will be having the sufficient information. From observation of xt graph you can say car is moving forward up to b, and from b it takes a u-turn and it is coming back to c, यहाँ पे आ रहा है. बट st ग्राफ को देख के यू कांट से कि वेदर द xt ग्राफ वाज सेम एज st ग्राफ या कार ने यू टर्न लिया. यू कैंट गिव द सफिशिएंट इन्फो क्योंकि उसमें होगा ही नहीं. सो xt ग्राफ विल बी हैविंग द सफिशिएंट इंफॉर्मेशन. सो 99% क्वेश्चन विल बी हैविंग द xt ग्राफ ही देंगे. दे विल गिव यू पोजीशन वर्सेस टाइम ग्राफ बिकॉज इट विल बी हैविंग द एंटायर इंफॉर्मेशन, and using that xt graph you can conclude everything, है ना. You can calculate velocity, you can calculate speed, everything you can calculate. Clear? So 99% question will be having xt graph. तो आपको you should know the proper analysis of xt graph, displacement versus time और position versus time. Clear? So हमने ये देख लिया था कि average velocity is delta x upon में delta t and instantaneous velocity is dx by dt. So just tell me. अच्छा ये मैंने बताया था कि when you draw a curve in maxima minima, we have covered this topic. Whenever you draw a curve, when you take y dash, what y dash gives you? Y dash क्या देता है? Slope. It gives slope at that moment, है ना. Y dash give you slope at that moment. यहाँ पे क्या slope है? And what will be your average slope between 2 points? Suppose if you are drawing 2 points a and b, so what will be the average slope between these 2 points? That will be this delta y upon net delta x. Clear? So what will be the slope between a and b? That tan theta is equals to delta y by delta x. Clear? अरे स्लोप ऑफ लाइन विल बी परपेंडिकुलर बाय बेस ना. tan थीटा इज इक्वल्स टू परपेंडिकुलर अपॉन में बेस. क्लियर है कि नहीं?
हाँ सर.
चलो.
Sir,
हाँ
can you explain me this graph again? I got disconnected.
चलो, आई एम ड्राइंग दिस ग्राफ अगेन. इन मैक्सिमा एंड मिनिमा we had covered this topic, कर ही लिया था पूरा. that whenever you draw a graph y versus x, when you take y dash at a particular point, y dash, this y dash will give you slope at that point you will be getting the slope. ठीक है. suppose if you are getting slope at b, that is y dash, तो यहाँ पे slope, when you differentiate this curve at the point b, you will be having the slope. Y dash will be the slope. But when you connect these two dots a and b and you take out the slope of this line AB, when you take out the slope of this line AB, this height will be delta y and this length will be delta x. So what will be this tan theta? This tan theta will be equals to perpendicular by base. So that is delta y by delta x. Clear? समझा?
Okay, sir, understood.
Now I will draw this graph. यहाँ पे मैं फिर से इसको लूँगा. देखो this graph. इसको नहीं, नया ग्राफ I will take, न्यू ग्राफ I will take. चलो. We are taking xt graph. xt graph को we will draw. So xt graph is like this, ऐसा है, like this. Okay. This is point B. this is point A B, and this is कौन है यार बेटा, please check your mic. This is point C. If object is moving from A to C in this motion, ऐसा जा रहा है, and question is asking about the average velocity and instantaneous velocity, तो ग्राफ से कैसे निकालेंगे? How you will calculate average velocity and instantaneous velocity just by observation of graph? तो ऐसे करेंगे. When you take instantaneous velocity at B, then you have to take the slope, है ना, you have to take the slope. अब यहाँ पे क्या है, dy by dx will give you the slope. In the same way in xt graph dx by dt will give you the slope, है ना, क्या देगा, it will give you slope. तो पहले क्या करेंगे, first if you want average velocity between A and C, you just need to connect these dot, है ना, just connect A to C, A को C से connect कर दो, take this point, है ना, and take out the, थोड़ा सा A को और नीचे कर रहा हूँ मैं, A को और नीचे ले लो, यहाँ पे ले लो, this is A, और B को थोड़ा सा और ऊपर ले लो, we take C यहाँ पे, we will take C. So when you connect these dot A and C, अगर question is asking about the average velocity between A and C, तो बताओ average कैसे निकालोगे? This will be your XA, हाँ या ना? Observe करो भी, याद मत करो, है ना? This will be your position at XA, position at A will be XA, position at C will be, position C पे क्या होगी? What will be the position at C? बताओ.
XC.
It will be XC. थोड़ा सा नीचे करो इसे, this will be your XC. So the position at C will be XC. So what will be the net displacement between A and C? What will be the net displacement between A and C? It will be delta x. This will be delta x. Clear? That will be XC minus XA. क्या सही है? Is it correct?
Yes, sir.
And what about time? This is time TA. This is time TB. Clear? So what will be delta T? Delta T क्या होगा? What will be delta T? Delta T will be equals to, this is not TB, this is TC. TC है. TC minus TA. Clear? Is it clear?
Yes, sir.
So what will be the slope of this line? इस line का slope क्या होगा? Tan theta. That tan theta is equals to delta x by delta t. That is the average velocity between A and C. Is it clear? क्या ये समझ में आया? ये मैं बताना चाह रहा था कि when you take the slope of a line, when you connect two dots, you take the slope of that line, that slope will give you average velocity between, ये सिर्फ magnitude लिया है ना, अब ये मत बोलना सर that is the average speed, I am taking the magnitude, है ना, magnitude ही लिया है सिर्फ मैंने ऐसे, when you take the magnitude, so this slope will give you average velocity between A and C. The slope of this line will give you average velocity between A and C. But when you have to calculate instantaneous velocity at B, suppose question is asking about that at a particular instant, suppose at B you have to calculate instantaneous velocity. तब क्या करोगे? You will take instantaneous version क्या होगा? यहाँ पर थीटा या अल्फा ले लो, this will be your dx and this will be your dt. So instantaneous velocity V instantaneous will be equals to dx by dt. Clear है कि नहीं? Is it clear? So when you take instantaneous velocity, आपको क्या कैलकुलेट करना पड़ेगा? You have to calculate dx by dt एंड व्हेन यू टेक एवरेज दो पॉइंट के बीच का, तो किसी भी एक्सटी ग्राफ का ऑब्जर्वेशन से कैन यू कैलकुलेट इंस्टेंटेनियस एंड एवरेज, ये निकल जाएगा, बोलो निकाल सकते हो?
Yes,
ठीक है,
sir.
so that's about average velocity and instantaneous velocity. Clear? Is it clear?
Yes, sir.
चलो इसे नोट कर लो, थ्योरी पार्ट यहीं तक रखेंगे आज।